Testing heat in a single stage heating system. First, we'll start with the thermostat. With our breakers on, our thermostat set to off, and our fan set to auto, remove the cover to the thermostat. Noting this system has 7 wires. This is a 2-stage heating system. We can still use this system to show how to test for a single stage heat. For this demonstration, we removed our orange wire, which is the reversing valve, and our black wire, which was going to our heat strips. In a straight air unit, you could have 4 to 5 wires. In this unit, we have 5, the 5th wire being a common wire which powers your thermostat. Starting from right to left, we have our blue common wire, which powers our thermostat. We have our green, which goes to our indoor fan, our yellow, which is our cooling coil, our white, which is our heat coil. In this case, it's a single stage heat, so it will be powering our heat strips. The final red is our 24-volt power. With our breakers on, thermostat off, fan auto, and we pulled our cover, we will start by setting our meter to VAC. Holding one lead to our red 24, we will go in order of each of these wires. And then to yellow, and then to green, and then last our common, or blue. We should have a reading 25 to 30 between all of those wires, between red, white heat coil, red and yellow cool coil, red and green fan coil, red and blue common. You should have a reading between each of those with the breakers on and the thermostat set to off. This thermostat is a 2-stage heat, 1-stage cool. For training purposes, we will be using the emergency heat mode. This will act as a single stage heat. Setting our thermostat to emergency heat. We are 69 in the room currently, calling for 65. We will turn our temperature up to 71 and verify the unit comes on. On the opposite side of the wall of our thermostat, we can see our low voltage wire coming from our thermostat to top a unit to the junction. In this junction is where our low voltage wire from thermostat and our low voltage wire to outside unit meets. Outside, we'll go down and follow the line set to the outside unit. Inside thermostat wire, we'll go over to the thermostat. At this junction, on a single stage heat system, you will have your red 24 volt, your yellow cooling coil, your blue common if you have it, your green fan coil. Go into our breaker panel, looking for a label, 3 and 4, 5 and 6. We have 3 and 4, 5 and 6. To verify our system is down, we will take our multimeter and set it to VAC. We will find our main lug entrances, which are main power coming from breaker to in unit. Will come down. You can see one in the back to the left and one in the back to the right. We will test across those and verify we have no power. So testing across both of those terminals. We have no power. Our breaker is functioning. Looking at our schematic, we can see our thermostat. We can see our left to right, our white heat coil, our green fan, our red 24, our common, and our cool. So white being our heat coil, that is our focus. We can actually follow this white. We see it is a white wire, and it's going to 1 through 9. This says it's a plug receptacle connection. We can see all of our different colors here for what's coming out of the plug, and that's how we can verify our terminal here. So, our white coming from thermostat, coming down, coming into plug, and it says C note 3. Come down here, it's an auxiliary. It just says note number 3. Used with auxiliary heat kits only. Auxiliary heat would be your second stage heat if you have a heat pump. If you do not have a heat pump, this auxiliary heat would be your first primary heat. In this case, it would be our primary. So, with that being said, this schematic is not going to assist us with our heat sequencer or our heating strips. Coming into plug, it'll say C note 2. It'll be the same. It will be the same note. Brown and white wires are used with auxiliary heat kits only. If we look up to our heat sequencer, we will see our brown and white wire. We will see one lug to our heat strip there. And we will see our second lug, which will have a thermal fuse there. With this diagram not assisting us, and it's saying that brown and white wires are for adding heat strips only, we can go back to our thermostat junction and find our brown and our white wires. These will tie in from our thermostat wires coming from our thermostat, going into our unit, coming down is brown and white. Brown and white wires will go into this junction, come out of the junction on the other side, staying brown and white. They will go straight up to the heat sequencer. This heat sequencer is a thermodisc. So when you turn your thermostat on, set it to heat, power will run through and heat this thermodisc. When this thermodisc heats up in here, a rod will come out, closing the circuit and sending power out. You will have one leg coming out, going straight to one side of your heat strips. And you'll have one side coming out from your main power junction box. This one is powered all the time, and this heat sequencer breaks that. This is an open circuit until your heat turns on, sending power through your heat sequencer, heating up that thermodisc, sending the rod down, and closing the circuit between here and here. Setting your multimeter to microfarad continuity ohm setting, you need to manually select to change that mode until the continuity symbol shows. Otherwise, it could manually change to microfarads and give you an improper reading. With it set to continuity, taking your meter ends and touching them together will create a beep, letting you know there's continuity. Coming back to our heat sequencer, without getting a call, we should have open line between our white and brown from thermostat and our power out to heat strips. With the thermostat off and not calling for heat, if you have continuity between those two terminals, the thermoplate inside of this is bad, forcing the rod to stay down and closing the circuit at all times. This heat sequencer should be replaced. These steps are exactly the same for these two terminals. A closer look at this heat sequencer. Notice the H15-45 and the C40-110. What that means is simply hot. So when that thermostat sends the heat call, it has 15 to 45 seconds before it closes this circuit. When the thermostat is cut off, it has the C cold 40 seconds to 110 seconds before this opens back up. So H15 to 45, brown and white thermostat wires. Heat call is turned on at thermostat. This heats up. Raising that thermoplate and pushing that rod up, closing the circuit between here on the two lowers and here, and it will close that circuit within 15 to 45 seconds. Once the unit has reached its temperature and the thermostat ends the heat call, the fan will continue to run to cool the heat strips and cool the unit for 40 to 110 seconds. Again, when testing this heat sequencer, your two lowers and this lower cross this way. Receives power all the time. Your upper terminals, even if there was a second stack, does not receive power until the thermostat is on, the heat is calling. It has been 15 to 45 seconds. The thermal plate will expand, pushing the rod up, closing the circuit between the top and bottom. If you were not calling, or if you're bench testing this part, you would simply test between your upper and lower. That should be a complete open line OL. The second side should be exactly the same. You should have complete OL. If you were testing in ohms and not continuity, 0.00 or 0.01 ohms is not the same as open line. You should have open line between these two, lower and upper, or lower, middle, and upper on a double stack. Should always be OL. If you were testing in ohms and you have 0.00 or 0.01, this part is still bad if it is not a true open line. Our transformer, located in the back of the AC unit, is responsible for taking that 120 or 240 volts of power and transforming it into 24 volts of low volt power. On this transformer, at the top left, you can see the red wire. Under the red wire is a label for 24 volt. That's our 24 volt low voltage. And you can see the common wire. On the right top, 2 yellow wires coming out, going over to our board. Those common colors will change leaving that board. Most common is blue. On our lower half, we can see this label. You see that this transformer is either a 208 volt or a 240 volt. This is a 240 volt system, so it needs to be wired to 240 volts. Continue reading the diagram and you can see that 208 volts would be a yellow wire at the bottom left, and 240 volts would use an orange wire at the bottom left. In this case, we're using an orange wire to make it 240 volts. Coming down to our diagram, we can verify that these colors are correct. We look for our transformer label. We can see our 24 volt low. This symbol is a coil. We can see our 24 volt coming out of our main 24 is red, going to our fan timer. We can also see our secondary 24 volt coming out. Our common is yellow, running over to our common side of the fan timer. Our main power that powers this transformer will come from a terminal block in the system. We have our common and our 230, 240, 240 in the system coming out as blue and orange. We've seen that blue and orange wire on the bottom of our transformer. Blue and orange. Coming back to our schematic here, we have blue and orange coming into our plug. Coming out of our plug is blue and black. This will come to our terminal block. Our terminal block is our main line 1 and line 2 in. One leg of 120, one leg of 120, 240 volts across. Our terminal block located here with line in, and ground. This is just simply a junction to distribute power through the system. So the blue common and our black off of our junction follow up to our plug. There. Follow it out is our blue and orange wires. We're zip tied and looped in this one, but we come right out and we go into our transformer. Testing this transformer on our low voltage side, we will unplug our red 24 and in this case our yellow common. We will set our multimeter manually to continuity again. And we will test across that top left pin and the top right pin. We should have continuity. If you do not have continuity between those two terminals, the transformer is bad. This concludes troubleshooting on a single stage AC unit, single stage heat AC unit. This would be the same for checking the second stage heat on a 2-stage heat system, one that has a reversing valve with the heat pump. For testing a unit with 2 stages of heat, similar to single stage, the extra wires added would be a black wire going to heat strips and a white wire for your first stage heat, and then an orange wire for your reversing. So the wires added would be black or brown and your orange wire. For testing the components of the heat strips, it would be the same as a single heat stage AC system. The difference in the two is in our wires coming from our thermostat to our junction and going to outside, we would have our extra wires. We would have our white going just like the standard single stage, our red low volt, our blue common, our yellow cooling coil here, and then we would have our added black in this case going to thermostat for our second stage, which would be our heat strips, and our orange wire going to the outside unit reversing valve. For checking a system with two stages of heat, first being the heat pump with the reversing valve, and second being the inside heat strips, after verifying the heat strips are properly functioning, you would come to your outside unit. You would check this outside unit the same exact way you would for AC. The only difference being is your pressure line would be cold and your larger suction line would be warm. That's because the Freon is flowing in opposite directions.